Every year, 92 million tons of clothing are thrown away. But instead of simply disappearing, a large portion of these textiles is now being reintroduced into the production chain. Clothing recycling is reshaping the circular economy of fashion and opening a new chapter for the global industry's sustainability efforts. Behind every worn, frayed, or faded piece of fabric lies a complex technological journey. Collection, sorting, cleaning, shredding, fiber separation, until each filament is transformed back into yarn, then into fabric. At the heart of vast recycling plants, operating day and night, textile waste is silently converted into raw material for the next generation of products. To understand the true power of this industry, one must examine each step in detail, from the moment clothes are discarded to the moment they are reborn as new materials, ready to begin a completely different life cycle. From a once marginal idea within the textile industry, clothing recycling has become a full-fledged economic sector, now valued at over $9 billion, with projections to double in the next decade. Every year, millions of tons of discarded clothing fuel a new kind of supply chain, where waste becomes a resource and where technology transforms the way the world perceives materials. Today, more than 250 large-scale textile recycling facilities are operating in Asia and Europe. Each ton of recycled fabric saves up to 75,000 liters of water and reduces nearly 1,800 kilograms of CO2 emissions, making it one of the most resource-efficient processes in the entire fashion industry. From cotton and polyester to wool, these factories close the loop between waste and production, forging a future where every discarded fiber can find new value for the planet. Think back for a moment. What did you do with clothes that no longer fit? Did you throw them away, give them to a friend, or leave them at the back of a closet? This answer, shared by millions of people worldwide, became the starting point for a powerful textile recycling industry. This story doesn't begin in a factory, but in the heart of cities, where collection containers are located in shopping centers, apartment buildings, and even fashion stores. Every week, specialized trucks collect piles of used clothing. Each bag is filled with clothes that once held a story. Some items are redistributed to charities, while the rest are sent to recycling centers, where their second life begins. What was once considered mere waste is now treated as a raw material. Amidst mountains of faded and torn fabrics lies a simple yet profound truth. A garment is only reborn when someone decides not to throw it away. When bags of clothing arrive at the recycling center, they don't immediately go into the machines. They must first go through one of the most meticulous steps: sorting. Every garment, every piece of fabric is unfolded and inspected. Every seam is examined to determine the material, color, and degree of wear. Much of this work is still done manually, as only the eyes and touch of an experienced operator can distinguish a cotton polyester blend from pure polyester. Alongside these manual processes, optical scanners and sensors assist in identifying thousands of items per hour. The accuracy of this step determines the quality of everything that follows. This is where the true foundation of textile revival lies. Before discarded garments can be reborn, they must be stripped of everything that isn't textile. Each piece passes through a metal element removal system where buttons, zippers, staples, eyelets, and plastic logos are removed to prevent damage to the machines in subsequent stages. When only pure textile remains, the material is sent to the cutting and shredding section, the heart of mechanical recycling. On the conveyor line, industrial blades move with rhythmic precision, cutting the garments into small pieces a few centimeters across. The fragments then fall into enormous shredders, where hundreds of high-speed spinning steel knives tear the woven fibers apart and transform them into a soft, fluffy material, similar to shredded cotton. The fiber dust is continuously extracted by a high-pressure air system, while industrial magnets capture any remaining metallic residue. Once this fragmented mass takes shape, it is directed to the washing and cleaning area. There, hot water, steam, and bioenzymes remove any remaining dirt, grease, and dye residue from the fibers. Multi-stage washing tanks ensure that each fiber is perfectly clean without altering its structure. By the time the material emerges from this section, it is no longer worn clothing, but raw textile material, ready for the next stage: fiber separation, and spinning into new yarn. The fiber bundles then pass into the carding system. High-speed cylinders, lined with fine metal teeth, stretch and untangle each filament. Streams of pressurized air expel dust and residual particles, keeping the fibers clean and stable. Optical sensors identify fiber types in real time, while air valves redirect cotton, polyester, and wool into separate channels. Finally, the purified fibers are compressed into uniform bales. This is the precise moment when discarded textile becomes a refined material, ready for the spinning stage. Freshly cleaned fiber bales are conveyed to the spinning area, where rows of sharpened looms operate continuously under the bright white lights of the workshops. Each rotating spindle holds thousands of fine strands, which are stretched and twisted uniformly by speed-controlled motors. Electronic sensors monitor the tension of each filament to prevent breakage. On the central control panel, twist, density, and spin speed data are updated in real time, allowing technicians to adjust each spool to the millisecond. The constant hum of the machines fills the air, the rhythmic pulse of a factory in operation. Every minute, meters and meters of new yarn are carefully wound onto their spools. At the end of the line, these soft, shiny yarns, uniform in strength and thickness, are scanned by optical sensors before being sealed, labeled, and placed in storage. From this moment, the material is ready for the next stage of its journey, becoming fabric again. Each spool of yarn is placed on the looms, connected to thousands of spindles that run the entire length of the machine. The central control system is activated, and hundreds of heddles begin to move rhythmically up and down, interlacing the warp and weft threads to form the first sheet of fabric. Each loom is precisely calibrated for tension, yarn density, and weaving speed according to the type of material being produced. Laser sensors monitor every yarn crossing in real time, automatically stopping the machine at the slightest misalignment or broken thread. In this enclosed space, the repetitive clatter of the heddles and shuttles resonates like the heartbeat of the factory. Gradually, a new fabric emerges, smooth, even, and lustrous, carefully wound onto a wide roller at the end of the line, ready for the next stage of processing. The freshly woven fabric is wound and sent to the finishing section, where cutting, washing, and dyeing machines operate continuously. First, the fabric passes through an enzymatic washing bath to soften its texture. Then, it is pressed and dried before being introduced into a fully enclosed, high-pressure dyeing unit. The color is applied uniformly using electrostatic spray nozzles, ensuring even distribution of pigments on each fiber. In the next step, a heated calendar smooths the surface and stabilizes the fabric's dimensions. All parameters, temperature, pressure, and time, are monitored in real time by a centralized computer system. Once the cycle is complete, the finished fabric passes through an automated inspection tunnel where industrial cameras scan every centimeter for weaving defects or color variations. Only rolls that meet all quality criteria are sealed, labeled, and transferred to the storage area, marking the completion of the recycled fabric production cycle. From mounds of old clothes, the recycled fibers continue their journey into the world of denim. Each thread is coated with a dense protective image solution to ensure strength and stability before the indigo dyeing process begins. Along the dye line, which stretches for dozens of meters, the recycled threads are repeatedly immersed in indigo baths. Each immersion is followed by an oxidation phase, which gradually intensifies the characteristic blue of denim. Optical sensors regulate the color intensity, ensuring that each thread emerges with the same deep shade, ready for weaving. Unlike conventional fabric, denim is woven in a distinct twill weave, where white weft threads intersect blue oak threads. This structure naturally creates light-dark contrasts as the fabric ages. In the weaving room, hundreds of looms work in perfect synchronization, their shuttles moving back and forth thousands of times per minute. The central control system monitors yarn tension and the precise angle of the twill, essential parameters for determining the strength and elasticity of the denim. Laser sensors track the uniformity of each weave point, automatically correcting even the slightest deviation. When the first roll of denim appears, its surface reveals its characteristic diagonal lines. This technical signature makes the fabric exceptionally robust and timelessly beautiful. Once off the loom, the denim enters the finishing phase. It is washed, softened, and given its typical faded texture through pumice stone or bioenzyme treatments. After drying and pressing, each sheet is inspected for softness, color, and elasticity before moving to the cutting and sewing area. From the softened and dimensionally stabilized rolls of denim, the process moves to the cutting area where the fabric begins to take shape as a finished product. Layers of fabric are stacked and held in place by a vacuum press to ensure maximum precision. Automated cutting machines follow digital patterns, their heat-resistant alloy blades slicing through dozens of thick layers of denim without distortion. Each component, leg, pocket, waistband, belt loop, is numbered and sorted before being sent to the sewing line. In the garment workshop, hundreds of specialized machines work in unison, each performing a precise operation. Twin needle machines for the main seams, overlockers for pocket edges, chain stitch units for decorative finishes. Steel alloy needles pierce the dense denim at high speed, while electronic sensors regulate thread tension to ensure even stitches. Polyester or waxed cotton yarns are used for their strength, and their contrasting color has become one of the visual signatures of classic jeans. Operators inspect each piece directly at their workstation, checking the alignment of the seams and the correct placement of reinforcements in stress areas. Once approved, the jeans move to the next stage, where buttons, rivets, and zippers are attached, transforming the textile structure into fully functional garments. The assembled jeans bodies are conveyed to the accessory attachment area, where rows of hydraulic presses operate at a constant pace. Metal buttons, rivets, and zippers are automatically fed by vibratory bowl feeders and firmly pressed onto the most stressed points, such as the pockets and waistband. Each press movement is precisely regulated by pressure sensors, ensuring sufficient force to attach the accessory without distorting the fabric. At the end of the production line, leather tags and brand labels are hot stamped using metal dies, adding the final touch of identity to each pair of jeans. In this era of refined finishes, technology is giving way to craftsmanship. Machines now play only a supporting role. Ultimately, it is human hands that define the style and character of each pair of jeans. Skilled finishers use sandpaper, pumice stones, and stiff brushes to distress specific areas of the fabric, knees, back pockets, waistbands, creating natural fades and highlights that mimic years of wear. What appears simple actually requires precise expertise. Too much pressure can tear the fabric. Too little leaves no visible trace. Certain details are refined with airjet tools or light brightening sprays, allowing the indigo to gradually fade to the vintage tone desired by the designer. Each pair of jeans is then hung individually in a light-controlled booth where artisans assess the color balance under different lighting conditions. When the shade achieves the desired harmony, the jeans are steamed to further soften the fibers, stabilize the shape, and smooth any creases. No two pairs are exactly alike. Each wash, each distressed edge bears the unique signature of the finisher. It is this individuality that transforms a simple pair of jeans into a unique piece marked by human touch, time, and technique. As the process moves toward the final inspection area, the rumble of the large machines fades, leaving only the soft rustle of the fabric being folded. Each pair of jeans is laid flat and examined under intense white light. Every seam, every wash, every fiber is inspected to verify its durability and consistency. Only pieces that meet all the criteria are marked, precisely folded according to predefined templates, and then sent to the automated packaging line. The finished jeans are carefully stacked in boxes, sealed, and recorded in a digital system to ensure traceability. At this final stage, each product undergoes more than just a quality control check. It attests to a complete cycle of renewal, a transformation of discarded fibers into a new pair of jeans. The journey of an old shirt doesn't end in a landfill. It continues inside factories, where materials are regenerated and redefined. Discarded clothes become fibers, fibers become denim, and denim is reborn as new garments, carrying within them the spirit of sustainability. At every stage, from sorting to finishing touches, Humanity's efforts to transform waste into value and reinvent the relationship between consumption and the planet are reflected. If you believe fashion and the environment can coexist, share your thoughts and reflections in the comments and tell us what sustainability means to you. Every opinion, every perspective contributes to shaping a future where innovation and responsibility go hand in hand. If you enjoyed this documentary, don't forget to like, subscribe, and turn on notifications so you don't miss any of our content. But don't go away just yet, there's more. The rest of this video will be just as exciting, so stay with us until the end. Every year, more than 1.2 billion fashion items are made from wool, a material that seems simple but has maintained its place in the industry for centuries. But what makes this fiber so durable? Behind every thick sweater, scarf, or coat lies a complex and meticulous process. Beneath its soft surface unfolds a veritable chain of transformation. Wool is sheared, washed, carded, spun, and finally woven into fabric. At each stage, nature's raw gift is refined by human skill and modern technology. From windswept pastures to factories operating day and night, one truth remains unchanged. Wool transforms the seemingly ordinary into a material capable of supporting an entire global fashion industry. After centuries of existence, it remains a cornerstone of the global textile industry. Every year, more than 2 billion kilograms of wool are harvested from the vast pastures of Australia, China, and New Zealand, three nations that alone supply more than 60% of global production. From vast farms covering thousands of hectares, this raw material enters production lines to become sweaters, scarves, home furnishings, or high-performance insulation. The economic value of this industry exceeds $80 billion annually, including exported raw fibers and finished textile products. China is currently the largest processor and consumer of wool, while Australia dominates the production of fine, high-quality wool. But beyond commerce, wool embodies one of the world's most renewable natural fibers, a lasting link between nature and technology, and a pillar of sustainable fashion with a history spanning millennia. The journey of wool begins in the vast open pastures of New Zealand and Australia, where farmers manage their flocks according to strict standards to ensure a clean and uniform fleece. Each farm selects its breeds based on its specific goals. Merino wool is used for ultrafine fibers, while Romane, or Corridal wool, produces longer, stronger strands that are easier to weave. Each sheep is identified and registered, with precise information on its age, health, and fleece yield. The flocks graze in rotation to preserve soil fertility and prevent overgrazing. Their diet, enriched with hay, grains, and minerals, promotes thick, uniform, and lustrous wool. Dry, well-ventilated sheepfolds prevent parasites and skin diseases. Each season, farmers vaccinate, deworm, and inspect the animals, as the sheep's health directly determines the quality of the fiber. Before the breeding season, ewes undergo a flushing phase during which their diet is increased to boost fertility and produce strong lambs with finer wool. During lambing, the ewes are closely monitored to ensure the newborns are born quickly. A few weeks later, the lambs are identified, weighed, and then moved to richer pastures for weaning. When the warmer months arrive, the flocks are washed, treated for ticks, and then naturally dried before shearing. Each animal is handled gently to avoid stress and ensure a full, clean, and undamaged fleece. After shearing, the sheep are inspected, any minor cuts are treated, and they are then returned to pasture. At every stage, from feeding and care to shearing, animal welfare standards are meticulously observed, as only healthy ewes produce pure, strong, and high-value wool. After several months of growth, when the fleece is mature and the weather warms up, the shearing season begins. This time ensures the sheep's comfort and allows them time to rebuild their wool before winter. Before shearing, the flock is placed in clean, dry enclosures and lightly fed to keep it calm and stable. The shearers, true specialists, use precision electric clippers following a rigorous sequence. belly, legs, flanks, shoulders, then back. The goal is to remove the entire fleece in one smooth motion, without breaking or damaging the fibers. An experienced shearer can shear 200 to 250 sheep a day, which is barely 1 to 2 minutes per animal. The dirtier, shorter parts of the belly are reserved for industrial products, while the long, white wool from the back and flanks is destined for high-end textiles. After shearing, each sheep is examined, disinfected if necessary, and then left to rest. Each fleece, the result of a year's care, becomes the first raw material in the industrial journey of wool. From the shearing sheds, the freshly cut fleeces are sent to the sorting areas, where human expertise remains essential despite automation. Each fleece is laid out on a large table and examined according to the color, length, and fineness of the fiber. Soiled or too short sections are removed. The sorters separate the wool according to its origin. The fleece from the belly and legs is used for industrial purposes, while the fleece from the back and flanks is used for fine textiles. This meticulous sorting maximizes the value of each fleece and ensures perfect uniformity before baling. These bales, compressed by powerful hydraulic presses, weigh between 130 and 180 kilograms and are then wrapped in burlap or heavy-duty plastic. Each bale is labeled with detailed information: farm of origin, sheep breed, wool grade, guaranteeing complete traceability throughout the supply chain. These pristine bales are then transported to washing plants, where industrial processing begins: washing, degreasing, purification. In the processing area, the wool is first mechanically opened. High-speed rotating metal tooth cylinders separate the fibers and remove dust, grass, and dirt. This process facilitates water absorption during washing. The washing system, consisting of 6 hot water baths at approximately 80 degrees Celsius, first uses a soapy solution to dissolve the lanolin, then clean water for rinsing. Between each bath, pressure rollers remove the dirty water without damaging the fibers. Sensors adjust temperature and airflow to maintain optimal quality. The recovered lanolin is refined and reused in cosmetics and pharmaceuticals. The clean wool then passes through a rotary dryer where hot air circulates evenly. The result is soft, shiny, perfectly dry fibers ready for blending. In the packaging workshop, the dry bales are fed into a mixing machine. The batches, varying in color or fineness, are weighed and homogenized by spiral rollers. The air is humidified to prevent static electricity. The fibers emerge light, soft, and elastic, ready for the carding machine. Carding realigns all the fibers in the same direction. The wool passes between several rollers fitted with metal teeth, rotating at different speeds. The fibers separate, straighten, and become finer. Suction systems remove the last impurities. At the end of the process, the wool forms a continuous veil rolled into a soft, even ribbon. This process restores cohesion and uniformity to the fiber, an essential basis for the quality of the fabric. In some artisanal workshops, hand carding with 2 interlaced metal brushes is still practiced. Although slow, this age-old technique allows for delicate control of tension and preserves the wool's natural elasticity and luster. Once carded, the wool goes to spinning, a crucial step that determines the yarn's fineness and strength. In modern looms, several rollers gradually stretch the slivers while the fibers are lightly oiled to reduce friction. Then, a twisting system winds them together to form a strong, homogeneous wire. Sensors monitor the wire's tension and regularity, while optical scanners detect any imperfections, which are immediately corrected by thermal melting. The wire is then wound onto standardized cones. In traditional workshops, artisans still use the spinning wheel, producing yarns with a unique character, often reserved for luxury pieces. Then comes the weaving, where the yarns become textiles. Before the process, sensors measure the tension, moisture, and density of the yarns. Thousands of strands are stretched across the loom, forming the warp of the fabric, while the weft is projected by a shuttle or a jet of air. Sensors detect the slightest break. At the slightest anomaly, the machine stops. The formed fabric is then inspected under powerful lamps, and minor defects are corrected by hand. The raw fabric then goes to finishing, fulling in warm water, fine carding to soften the surface, dyeing, steam fixing, and low-temperature drying. The resulting fabric is dense, supple, and luminous, ready to become a coat, blanket, or suit. Finally, the rolls of fabric reach the cutting and sewing section, where they take shape. In temperature-controlled rooms, rotating blades cut each piece according to digital patterns. The pieces are then sewn together on twin needle machines, steam-pressed, inspected, folded, and labeled for global distribution. From these vast pastures to the sewing workshops, the journey of wool illustrates the delicate balance between nature and technology, tradition and innovation. If you enjoyed this documentary, please like, subscribe, and turn on notifications so you don't miss any of our content.